Welcome back, Geometry Scholars. Today's lesson is a continuation of ASA, SAS, and SSS triangle congruence. And today we're going to be proving that triangles are congruent using those three postulates. The central question for this unit is, how does algebraic knowledge of lines help to solve problems about geometric concepts? And the objective for today's lesson is that you will be able to determine if two triangles are congruent, and if so, explain why. So this particular set of notes is all proofs. We're going to be proving things. The first two proofs we're just giving the reasons for. The second two proofs will be giving the statements and the reasons. And I really want you to try to think if you can determine why maybe that's the reason, or even come up with the next statement before I do. Get your mind thinking about why these triangles could be congruent. So looking at example 1, we have to complete the proof. They have given us that two angles are congruent, and so we're going to go ahead and mark those angles. So angle MQP, which is this angle right here, is congruent to NPQ, which is that angle right there, and angle MPQ is congruent to angle NQP. So we already have those angles are congruent. So let's come down here, let's look at the statement. They have, their first statement is angle MPQ is congruent to angle NPQ. And how do we know that? Well, usually the first reason is always the given. So they gave us that. In the given, MPQ is congruent to NPQ, that's the given. The second statement is that MPQ is congruent to NQP, and that is also a given. They gave us that at the beginning as well. So both of those are the givens. We didn't have to guess. Whatever they give you is the given. Okay, and let me change these to blue so they stand out a little better. There we go. Okay, so next they say, well, QP is congruent to QP, so I'm going to mark that. QP, the line, is congruent to QP. Well, how do we know that QP the line is congruent to QP the line, or the line segment, rather? And we know they're congruent. If you were in class for today's practice, we know that they are congruent due to the reflexive properties. Let's stretch this out. Okay. So an item can be congruent to itself due to the reflexive property. So looking at these two triangles, now how can I prove that these two triangles are congruent? Think about what they have. They have an angle, and then they have another angle. Well, what's in the middle? What's the included? That's the side. Okay, so ASA, and forgive me for my poor smartboard writing. I'm doing this one on my computer, not on my smartboard, so the actual writing is a little shakier than normal. So looking back, we have an angle that's congruent to one triangle that's congruent to an angle of another, a side that's congruent to itself, and then another angle from one triangle that's congruent to another. So we have two angles and a side. So since two angles and the included side of triangle 1 are congruent to two angles and the included side of triangle 2, the whole triangles are congruent. That's all it takes. If we have the two angles on the side, the two triangles are congruent to each other. And hopefully you have figured out with my writing that that is due to the ASA postulate. And ASA stands for angle, side, angle. Okay, let's try our next one. Complete this proof. First, they give us that angle A is congruent to angle C. So I'm going to mark that angle A is congruent to angle C. And how do we know that? We know that because it's the given. It's the first given. Then they have that E is the midpoint of AC. Again, they gave that to us. E is the midpoint of AC, so that's another given. The next reason they gave us, the next statement they give us is that AE is congruent to CE. So let's mark that. AE is congruent to CE. Now, that's a little tricky. We haven't done a lot with this particular statement before, how do we know that AE is congruent to CE? It's got to be something that they've already given us. And looking back at statement 2, E is the midpoint of AC. So if a point is the midpoint of a line, it's cutting it in half. So since E, this point right here, is the midpoint of AC, the entire thing, it means it's cutting AC in half. And when you're cutting something in half, you're cutting it in 2 equal pieces. So the reason for that, the reason that we know that they are congruent is due to the definition of midpoint. Okay, the 2 lines are congruent due to the definition of midpoint. So what do we have so far? What do the 2 shapes right now have common? They have 1 angle and 1 side. So let's see what the next thing they give us. The next thing they tell us is that angle AEB, so AEB, so that's this angle right here. I'll mark it twice since I already have one marked once. It's congruent to angle CED. So it's congruent to that one. How do you think we know that? How am I allowed to prove that those angles are congruent? What kind of angles are they? Well, they are vertical angles. So we could say the vertical angles theorem, or you could write that vertical, and I'm going to say or vertical angles are, don't need to capitalize that, angles are congruent. Either of those options I would be okay with. They mean the same thing. The vertical angles theorem says that vertical angles are congruent. So you could write either of those. Okay. So looking now, what do these shapes have the same? They have 2 angles congruent as well as the included side. So these 2 triangles are congruent using what postulate? Well, it's the same one as the first example, the ASA postulate, or the angle side angle postulate. They have an angle side angle of triangle 1 is congruent to the angle included side angle of triangle 2. So the 2 triangles are congruent. Okay, let's just double check. We're good. So let's move on to example 3. This is where it gets a little bit harder. We have to complete the proof, filling out both the statements and reasons. And I will really walk you through the statement side. I want you to try to think of the reasons on your own before I get there if you can. Okay? So first of all, we can always start with the given. That's nice and easy. It's obviously nice that they give us something. So let me come back here. Sorry, copy this. There we go. Okay. So first of all, we would say that WX is congruent to YX. And you guys obviously can use the shortcuts for it. I'm on my laptop, so I don't have the shortcut for congruent, but you don't have to say it's congruent to, you can just write the congruent symbol, okay? So WX is congruent to YX, so we can mark it, but they've already marked it for us, okay? So that's this right here, WX is congruent to YX. And how do we know that to be true? Well, we know it to be true because it's the given. We don't even have to guess, okay? The next thing that we have is that Z is the midpoint of WY. So Z is the midpoint of WY. And how do we know that to be true? You guessed it. It's the given. Okay, they gave us both of those things. We don't even have to guess. Okay, let's think about our last one. Our last proof we had, they gave us that E is the midpoint of AC. So what did E do? E cut AC into 2 equal parts. So since Z is the midpoint of WY, they're telling us that for a reason, okay? If they're going to give us some information, then we're going to do something with that information. So since Z is the midpoint of WY, what does that mean happens? Means that WZ is congruent to YZ. So WZ congruent to YZ. And how do we know that to be true? How do we know that WZ is congruent to YZ? Well, it's because Z is the midpoint of WY and it cut it in half. So our answer for that is the same one we've already used in another prompt. We can say that they're congruent because of the definition of midpoint. A midpoint cuts something in half. So since Z cuts it in half, we have two equal pieces. Okay. Next, we have, notice I'm trying to prove them congruent. I'm trying to prove triangle WXZ congruent to YXZ. And I have a side and I have a side. So what else do I need? Well, we've learned side, side, side. So I either need another side or I need an angle in the middle. Okay, so I definitely have the two sides. I definitely have the two sides either here or here. So I either need this included angle or I need a third side. So looking at the angle, I would need this angle right here. Is there anything that I can use to prove that those two angles are congruent? I don't know that they're both 90 degrees. I don't know anything about them. So no, I cannot prove that those two angles are congruent. So I'm going to erase that. Can I prove that this side, XZ, is congruent to XZ? Yes, we have done this multiple times. XZ is congruent to XZ. And how do we know that to be true? Why am I allowed to say that XZ is congruent? Capitalize that. XZ is congruent to XZ. How do I know that XZ is congruent to XZ, or why am I allowed to say that? Well, when something is congruent to itself, it's due to the reflexive property of congruence. So you can just write reflexive property, or you can write reflexive property of congruence if you'd like to know the full term. Okay, so now looking at these, how can I prove these two triangles congruent? Is there enough information? Yes, there certainly is. I can say that they are congruent. Oops. Triangle WXZ is congruent to triangle YXZ. And again, you guys can use the shortcut triangle symbols if you want to. Since I'm on the computer, I'm writing it out the word, okay? And how do I know that those two triangles are congruent to themselves? What do they have the same? What do they have congruent? Well, they have three sides congruent to each other. So since it's three sides, that's the side, side, side postulate. Okay, they're congruent to each other given the side, side, side postulate. Last and final proof. I've noticed there's been a lot of writing. Hopefully working through these is helping you to understand them a little bit better. Writing the proof, what are we going to start with? I want you to fill out the first two statements and the first two reasons on your own, and then play the movie again. So go ahead and pause the video, fill out statements 1 and 2 and reasons 1 and 2 before you push play. Okay, hopefully you marked that AB is congruent to AD, and due to the given. And then angle 1 is congruent to angle 2, again, because of the given. So let's mark this on the actual shape. AB is congruent to AD, and then angle 1 is congruent to angle 2. Do I have enough information right here marked with the angles and the sides to say that they're congruent? Not yet. All I have is a side and I have an angle. So I either need another side to make it SAS, or since I have a side and an angle, I need another angle to make it congruent by the ASA postulate. Okay, so if I was going to use an angle, I'd have to use angle B and angle D. Is there any information that tells me that angle B is congruent to angle D? No, so I'm probably not using angle B and angle D. And so I'm probably not doing angle, side, angle. So then looking to see, to do side, angle, side, I have a side and angle. I would need this side right here. And is there enough information for me to say that AC is congruent to AC? Yes, we have done this multiple times. We can say that AC is congruent to AC. So I want you to fill out the next statement that AC is congruent to AC and tell me the reason. How do we know that AC is congruent to AC? And then pause. So pause the video, fill it out, and then press play. Okay, so you should have written that AC is congruent to AC. And again, you guys can be using, I mention this every time, the congruent symbols if you want to. I'm just writing the words. And we know AC is congruent to AC because of the reflexive property of congruence. So do I now have enough information to prove these two triangles congruent? And if so, how or what's the reason I'm going to use? So your final statement should always be what you're trying to prove. That is always your final statement. So if you have enough to prove this to be true, that's what you write as your final statement, and then give me the reason why. So go ahead and fill in your final statement with the reason. Okay, so your final statement was that triangle BAC is congruent to triangle DAC, and we know that to be true because of the SAS postulate. That we have a side angle inside of triangle 1 is congruent to a side angle side of triangle 2. Okay, so due to the SAS postulate, these two triangles are congruent. We have enough information about triangle 1 to say it's congruent to triangle 2 due to the side angle side postulate. Okay. Lastly, please write a summary of what we talked about. I know this was just proving things, so we've practiced proofs this lesson. We went through 4 proofs. The first 2 you just had to give the reasons, and the third and fourth one we wrote the statements. Sorry, the third and fourth one we wrote the statements and the reasons. Okay, and I will see you in class. Have a great day.